I wasn't really prepared before I clicked it. Rewriting dustmite in Haskell. Hey Ash, are you are you doing Haskell yourself, or are you making a joke? Alright, so I did collisions last night. Um, they aren't like the greatest thing of all time, but I thought I would at least just show it off. Um, so I mean, it isn't like, the fanciest thing, but the collisions are going off of the triangles. Um, so that's cool. I want to profile things before we get rid of the collision code is basically just taken from the other game engine. I mean, I definitely made it more correct this time. There is like some bumpiness that I have to figure out. Also, this interesting wall here is because I have some stuff that I need to clean up in the draw code. Does mine is better than collision? Yeah, I guess so. Um. Anyway, so basically, it's just there's nothing really fancy going on with the collision. It's literally just it just checks if we are within a triangle using the barycentric system of figuring that out, and then it just projects onto the plane, and then figures out if we are inside or above it. So it's very simple. There's no like crazy segment to segment collision code, which I couldn't figure out how to do. I was like, oh, you know what? I'll try and implement that because that's something that's cool. And then I realized that I'm not intelligent enough to do that. So berry-centric, yes. I wonder what berry it tastes like. No, it's berry. Is that how you pronounce it? Maybe I'm pronouncing it wrong, but um, anywho, it's it's this formula which I took straight from the other engine. I don't remember where I. Oh, this is the point in triangle. Yeah. This is what it is. This is what I got from the last engine. It basically just dots it with every edge, right? So that's pretty much it. Actually, I don't know if that's barycentric because I thought that barycentric was where you go counterclockwise or whatever. I don't really know. Anyway, we're moving on here. So what I did realize, right? What I have realized now is that we may have a problem. Now I'm not like the biggest like problem fan, but what I did last time was I basically made this acceleration structure, and I got it so that it clips triangles properly now. The problem with it is that there's just so many triangles because it clips them so tiny. And I've already tried deduplicating and doing all of this stuff. It just happens that it ends up being many triangles. So yeah, and by many triangles, I mean like the whole mesh starts out as about like 70 triangles, and then after we do all of the tree, I guess it's a KD tree with clipping, so it's kind of like a BSP. Is it efficient? The collision or the acceleration structure for the triangles? The collision is plenty efficient. The problem is how many triangles do we test against in a frame, right? The whole point of the BVH is, well, it's not really a BVH. It's kind of like a BSP. After I did my experimentation with it, but now it's not efficient because there's just too many triangles that we're testing against. I just want to see, yeah, I just want to have the ABB just to see it. But yeah, there are an insane amount of triangles. Like if we just I just want to see how many triangles just to prove what I'm talking about. So the mesh itself starts with like 80 triangles because it's just a blocky mesh. But this is how much it ends with. I just want to show that off, what I'm talking about. So I think I'm going to go back to the regular BVH. So after all of the work that I did yesterday, I think I'm just going to go back. So it's 487. That's actually not that bad. But that's 487 over the whole thing. And we have we are only going to depth 4. So if I put this to depth 6, then we have 873. It's honestly not that bad. It's really not like the craziest thing in existence. Like 873 really isn't that bad. Really what I want told you what a BVH is. Yeah, so a BVH is like it's just a way of grouping things. So let's say we start off with just one big box of things in 3D. And we just keep cutting them in half on the longest axis every time. But as we go down, we are partitioning them into different halves. So 876 dust mites. Yeah, that's way too many dust mites. Yeah, anyway, this is a lot of... Also, this is just really slow because it has to clip triangles again and again and again and again and again. So yeah. There's that. I could do it without clipping triangles too, but then it would just be a BVH, which the reason why I don't want to do a BVH is because earlier we had triangles that were just like, you know, leaves that just got massive, but I feel like it's better to have massive leaves without a lot of triangles than small leaves with a lot of triangles. I guess my proof here is that I want to see how many triangles we compare against every time we go through, right? So I just want to do tries plus plus. Just to see how many tries we're hitting every frame. Which is basically like how many tries are within our children. So we have 36, 43, 36, 27, 36, 25, 48, 31, 23. Okay, so somewhere between 20 to 40 tries per node. Which doesn't sound that bad, but it's kind of a lot. Think about what they could accomplish. Yeah, I think they'd all cancel themselves out with their like stupidity and bickering with one another. I think like I'm one of those people that like thinks like if I had like a double, I think we wouldn't get along. I think we'd be at odds with each other. So this is kind of fucked up because if the model has 70 tries itself, which I can check that real quick. If the model has 70 tries itself, then we're actually only cutting it in half, even though each leaf is cutting it in like, I don't know how many. And then this is how many tries the model has. 76. So we go from 76 to 36 over the whole model. I can guarantee you that if we were doing just a regular BVH, it would be a lot better than that. So I'm thinking that it might be time to call it a wraps on this, because this isn't a BVH. This is KD tessellate, KD clip. Yeah, because we're clipping triangles. So that's what I'm going to call it. But we aren't going to use it anymore. We are going to not use this anymore. We're just going to start from scratch. Well, not start from scratch, but we're going to just copy this and then make it much less complicated and just stay with what we had before. And just, so what I'm going to try to do is, instead, I looked this up, and what I can do instead of just doing centroids for the triangles is I can compare their bounding boxes, and that should give us a much more accurate split inside of a BVH. So I think that that's what I'm going to do. Such a short stream. Did I say stream? Oh, no. I'm not calling it. I'm not calling it. I'm calling it on this idea that I had yesterday, which is arguably more depressing than calling stream. Like this, that's quite depressing. This was quite depressing, because now I have to refactor all of this. The good thing is that we have a vertical split that we can do and look through the old code, because we need to copy the indexing that we used to have. The indexing that we used to have that we got rid of. Right, yeah, I already had this. Okay, so we can make this much simpler. We just have to make sure that we're using whole BVH indices instead of this, and not going to new faces. New faces are not existence anymore. The new faces and the new points were, we were basically physically splitting the arrays every time we went down. So love using old project code. Yeah, it's the best, because then I don't have to do it again. I'm glad that I didn't delete this, because then I would have been really, really up shit's creek, I guess is like the only real way to say it, you know? I would have been lost if I had to code it all again. But it's good. I'm already like familiar with this code, so hopefully it won't take too long. Hopefully it won't take too long. For now, I'm just going to keep the centroid as a thing, but we will see what we will see later. And this is whole BVH indices. All right, peace out, Ash. Good luck with that. Hey, what's up, Anna? I'm giving up on my triangle clipping stuff. We're just gonna go back to a raw BVH. Hate to say it, but it needs to happen, because I saw the amount of triangles and it was not a good amount of triangles, and so I've decided to give up. Hang my coat, because that shit is way too complicated. I mean, it's not too complicated. I got it working at the end, but was it worth it? Abso-fucking-lutely not, you know? And sometimes you have to admit defeat, and that's what it is. Okay. Okay, so down here, our left count equals I minus the parent first index. First index equals the parent first index. And then the count equals the left count. We have them separately, don't ask why. Parent count minus left count. Okay. Now inside of here, we're not going to have a depth anymore because that's not really useful for BVH. God, I'm so ready to never have to do a BVH ever again. After this is so painful. Now we're doing the centroid test at the end. We're going to change that, but that's fine. First index equals first, yep. And then moving down here, we have a lot less code down here, which is amazing. It really is. Okay. So instead of all of this bull fucking shit, yeah, we could just actually get rid of the whole thing. Oh my gosh, I've never been so happy to delete code. Oh my gosh, I feel like a kid on Christmas with deleting all of that code. It feels so good to rip that band-aid off. Oh man. Okay, just delete it. Just delete it. The way I'm talking about this code, you would think that it's code that didn't work, but it's code that did work. Just not good work, you know? Okay. And instead of going to this, we will go to BVH again. And we will go to BVH again. Okay. And we're back to... Also, this is whole faces.count. That should be fine. Okay. So now the next part is how do I change the traversal for when we're in our collision? That's the next thing we have to figure out. Where is the traversal? Here it is. Okay. So instead of going node faces count, we will go node count. How bad it feels to demolish red code. I deleted all the volume stuff. I ditched probe base lighting for software ray tracing. Wait, what do you mean? You mean the BVH that we were talking about? You deleted it already? That's crazy. No. Okay. Don't mind me hard coding the whole 0. Nothing has more than one hole right now. Giant probe grids encompassing the whole scene. I see. And is this going to be faster? Software ray tracing sounds expensive. So instead of J, we're going to go holes 0 dot leaf indices by J plus node first index. And that should be how we walk it. It should be that simple. It should be that simple. And now we don't have to do any of this nonsense with that. Inside of render, are we... Yeah, so let's just... We don't have node faces.count. Alright, let's give this a shot. Camera.c, not a... Why? Oh, it's a vector, I see. It's better for big open dynamic worlds. It's better. I see. It's the traversal that's doing it. You're talking about the bug. Yeah, I have no clue how intensive probes can get. I haven't done a lot of advanced lighting stuff, so. Alright, let's give it a shot. That wasn't it. We're probably going to segfault. Would you look at that? Okay, let's see what GDB says. We're at 1322. 1322. 1322. I go points, face indices. Hold on a second. I do malloc this, I do. Oh, I don't actually fill it with indices though. I don't think that that's the bug though. Oh, it is. Okay, so now we are testing against very limited triangles. Okay, but one try, two try. Okay, so we need to test more than just the centroids, it seems. So that's why we're falling through the floor. We need to test AABB against AABB. What's up, Sophie? What is up? Okay, so we're going to test, instead of centroids, we'll test the AABBs. So don't I have a function AABBs intersect? The problem with this is that I don't have per try AABBs, which I could set up beforehand. I think that may be the necessary thing to put onto the hole. That fucking sucks though. but I think it is necessary. I don't know if I need to make it a vector. You're asking it? Nice. Nice. Okay, so we want a malloc. We want an init vector whole leaf. No, not leaf indices. Try. Oh, I put this on mesh. Whoops. Fuck. You made your theme better? Nice. Try. Does init vector, when I give it a size, does it... Did I set it to... Yeah, I did. Okay, so then let's initialize it to the size of whole faces.count. Let's put this up here, and then when we iterate through, we want to get we want to cast vec. I don't know why. I don't know why autocomplete isn't working for me very well. Damn, that sucks. That reminds me of when I was probably in like 5th grade. I was at the lunch table. We had like a cafeteria lunch, and I just laughed so hard that my Gatorade just straight up, you know, like not just a little bit of a chuckle. We're talking about like whole ass table. Like I had a big gulp, and it just went everywhere. Like it was like, I forgot what somebody said to me, but it was like the funniest fucking shit I've ever heard in my entire life. And I just, you know, that's just how it goes, you know. That's pretty embarrassing. Alright, we're getting the centroids. We are getting the centroids. We also need... We're just going to name it points to be fast. What's the problem? Oh, it's just mad down here. It's good because we don't have to calculate the centroid later. That's nice. Why? What is the problem here? Oh, I didn't put this to vectory. Yeah, that's the problem with having like a vector implementation like this. Okay. I've compute A, B, B from points. Does compute A, B, B from points calculate the center? It kind of does it in a fucked up way though, where it doesn't do the centroid, but rather the center of the bounding box. But we can just calculate the center afterwards and just use this to calculate the bounds because I'm kind of fucking lazy and I don't want to do the bounds. So what I'm just going to do is I'm just going to pass in the points like this and go vec3 array. When I was learning C, I didn't know you could do that. It may get mad at me though for doing that. That would suck if it does. Use for undeclared identifier I. That. Oh, it's probably mad at this. Oh, it's because I didn't get rid of this. Okay. Alright, and so now we have the center and the ABBs. Okay. So now we should be able to, once we get the points and shit, just go, instead of points in AABB, just go AABBs intersect with the... Unfortunately, we are going to need to cast another thing. AABB pointer AABBs. Is it just me or is AABBs weird to type? It just is sort of hard to do two A's and then two B's. Okay. So we're just gonna go AABBs index by whole BVH indices I. Okay. All right, let's go and try it. One 117, 118. Mesh has no member named whole. Okay, I doubt we're going to go. We do fail. Let's see where. In vec3 centroid in 1323. We fail here. Why? Why do we fail there? What is a gubby? I need to know before I become one. I didn't touch that, did I? Oh, I malloc it after this. Shut the fuck up. That's a lot. What am I making? I'm making like a new rendering engine. I've made like a few engines. Okay, so we're still falling through the floor. And it seems like this doesn't get in the right BSP leaf. Gubby is the gubby that gubby serve at gubby. Now I'm gubbing with my friends. The fuck are you talking about? What? It seems like the left side specifically is pretty messed up. Okay. Okay. Well, that's not like the greatest thing that I've ever seen. I do kind of think, okay, so if ABBs intersect either way, we don't want to split down the middle. If I was going to fix this right now, I would say that instead of doing this sorting on the master array, what we should do is just do it internally. Just have arrays of indices at each level. Is that kind of a simulation thing? A lot of my stuff has been simulations, actually. But this is more of like a, I don't know if it's, a game engine, I suppose. Wait, hold on a second. I'm only going with the left child ABB here. Oh, shit. Then this is if... Oh, wait. This isn't supposed to be left. This is supposed to be parent. Okay. So far, so good. So far, so good. Okay, well, I'm glad that I figured out that bug before I, like, mental boomed and then tore the whole code apart. Alright, this is cool. So as you can see on the left side, maybe you can't see because of the bitrate and how fast it's going, but at max we're comparing against 10, 20 triangles. Just still a bit. Not gonna lie. This leaf seems fucking massive. Like, look at that leaf. It's just like the whole thing. So we have to figure out a way to get it down more. But the collision is working. I did this and can split thing, so this basically means that it has to have less than 3 triangles in them before it splits out. But then again, you still have this 20 here. Over here it gets more dense, but over there it still is 20. Yeah, I think maybe so I think the problem is that we're only sorting it into left and right, right? Where instead left might need, you know, indices that are in right. We can't just put them, just sort them right down the middle, because then we're gonna get large leaves like we're seeing. I think that's the problem. So how am I going to do that? It kind of seems stupid, but I was about to just like straight up allocate per depth indices and then just pass them down and then just free them at the end. So this would inherit the parent's pointer to an array of indices, and then we would copy it and then sort it into left and right. How are you number 3? That's crazy. That is crazy. Okay, so I'm gonna do that. We're gonna have size T pointers, indices. And over here what we'll do is we'll just allocate new ones. Of course you would love for this to be on the stack, but I mean, I don't really want to have a max face count. That sounds pretty bad. For simplicity's sake, we're just going to malloc this right now. We also need that. And do the same thing for right. And then at the end, we're just going to free it. Yeah, autocomplete is not working for me today. It's probably because I'm in the wrong function, huh? It is. Okay. Also important to free it in here. Lay high. That is some brain rot for sure. Whatever you're saying is some definite brain rot. That is absolutely true. So instead of going side by side here, we're going to do side by side, side by side. Okay. So we're just gonna go left indices count plus plus equals I. And we won't be using BVH indices anymore, actually. Instead of a global array, we'll just be using well, no, we'll be using indices I, which is the array that we inherit from the parent. And then instead of L swap T, we'll just have a second thing here that just checks it against the right child AABB. And then just add it onto right. And then we'll just have a for loop here instead. Okay. That's what the new loop is gonna look like. Excellent. And that should just be copy and pasted down here. Should probably actually just go outside of the switch case, but whatever, I don't fucking care. Okay. So now when we recursively call, we have to pass in left indices count. Okay, something that I didn't just realize actually is that we'll start with a large array. We'll start with an array of all of the indices. That's what we'll do. So we don't have to worry about that. And then at the end when we do this is still fine. All of that is still completely normal. You got chippies? Do you mean chips? Okay, so let's get rid of can split before we cause some bug. Okay. So all we need to do then is when we start out, instead of BVH indices, we need to malloc out okay. Let's see if we can go. Excellent. Okay, so there's something that I didn't take into account. Is zero memory. Realloc 1430. 1430, I do leaf indices. Okay, so I got rid of the init vector for leaf indices, I'm assuming. I guess so. I don't really know where it is. Oh no, I do init it here. I'm guessing that I have some heap corruption somewhere. Question is where. Let's just see depth. Fuck you, man. Okay, no. Yeah, it's immediately. Is immediately. Oh, fuck. I made a typo. Whoops. Okay. Okay, so now everything's just in one AABB. And why is that? I'm guessing that we're gonna get infinite recursion here. We don't. Okay. Oh, wait a second. We aren't doing left or right count. We're doing left indices count equals 0. Okay, now we might get infinite recursion. Okay, 10, 14, 10, 54. Okay, 54 is a pretty big one, huh? The weird thing is that these over here seem to split fine. And then that one just didn't split a single time. Oh boy. I hope I made a stupid typo and it's not the method itself that's the problem. Left indices count equals 0 or right indices count equals 0. Oh, I never pass right into here. That's what I get for copying and pasting shit. Okay. Was that infinite recursion that it detected? Yeah, that is. Oh, right. Yeah, you either have to have max depth or something. Let's try depth greater than or equal to 6. It exits out. See, it still is this center piece. I mean, now it's 14 tries, though. 20, 20, 12, 6, 20, 14. I mean, 12? See, it's just that part of the tree. It's not the rest of the tree. The fuck? Look at this. I need to put the new things on my glasses because this one's fucking up. Maybe I'm not supposed to do ABBs intersect, and I'm just supposed to do centroids. It's easy to test this. You just got to do dot center. What is Tasmania? Dustmania. Isn't Tasmania a place? I mean, at the end of the day, like 16 tries isn't ridiculous stupid mode, but like I just cracked myself up. I don't know why I said ridiculous stupid mode. What the fuck did I just say? What? Okay, I need to get this thing on my glasses. I have these pads that I need. Okay, I'm almost at the point. So I'm almost at the point where I might just like straight up fucking like try and figure out which one that isn't splitting, and then just like look at the indices themselves. Like I'm at that point with it where I'm gonna need to have a talk with it, because this shit can't be happening. Because right now we're just putting them in both left and right child. So they get their own arrays, which I thought that was the whole problem, that we didn't have separate arrays. Wait a second. I didn't. Oh. Wait, how is this working then? Dustmania to the mainland so people won't forget it exists? Like they do to Tassie? What is Tassie? That sounds sad. Okay, so this wasn't even working. That makes me remember Listomania. That song. Holy fucking shit. Yo. Alright. Taz/Tessie is slang for Tasmania. Oh, I see. Well, I'm so ignorant to Tasmania that I didn't even know. Okay, now we're splitting evenly. Now we're only testing it at 4 tries. 4 tries. 10 tries over here. Okay, 10 tries over here. 13 tries over here. 10 tries. 6, 8, 4, 8, 4, 8. Dude, this is a pretty good amount of tries. I mean, what was the max? 12? 12 is absolutely fine. 13? 13? What if we go depth 8? Now we're talking. Now that's a fucking 3, 5, 7, 3, 6, 4, 2, 5, 2, 4, 2, 4, 8, 6. The fucked up part is that they never split the other way. Oh, they do split the other way. Now I'm tripping. We need a better way than depth to detect it. Even in my home state, Victoria, nobody even remembers Tasmania. Yo, all I know about is the Devils, bro. The Tasmanian Devils, bro. Why am I talking about bro? Why did I just say bro? This isn't really a bounding volume hierarchy at this point. That's just a hierarchy. I want to try point ABB before we move on. I am about to move on. I know that this isn't like the most riveting thing to watch in the world. Trust me, I know. I'm the one having to code it. So I get it. But after this, we're gonna move on with our lives, so just want to make sure I get it right before we do any of the other systems. Tasmania, like you guys, you people from Alabama. Why Alabama? Tries 20 here. See, this is the exact problem that we had when we went by Centroid. Is that there are just massive triangles that just end in one leaf at the end. That's the problem with the Centroid test. Maybe there's like a different heuristic we could do. But I don't know. Why Alabama though? Are they like racist or something? When I think of Alabama, that's what I think about. Yeah, it may be cooked. It may be cooked. Alright, we're just gonna call it here. I'm gonna do the ABBs intersect. We just get better results out of it. I'm just gonna put it on a low depth. At least it partitions it fine. You know what I mean? Like it partitions it fine. It's not like the craziest partitioning in the world, but okay, so this is the per mesh partitioning. So this is the per mesh triangle hierarchy. And then underneath this, what we're going to have, or over this rather, what we're going to have is the bounding volume hierarchy for all of the shit in the scene. So that's what we have to either figure out now or we can postpone it till later. They used to dress up convicts there in medieval 1500s court clothing to stand out so they don't run away. Don't they do that in all prisons though? Like just like dress people up like crazy? I want to see if I go to depth 10. The reason why we're going to lag is because we're doing all of the AABBs one by one. And if we don't do that, I'm assuming that we're going to go fast. Yeah. So the only reason we're lagging with the high partitioning is just because we were rendering all of the wireframe ABBs, so take some 1500s gesture shit. People in the 1500s would think it's drip. Drip? That shit is drippy? That's crazy. Okay. Moving on. Here's something. So right now I have it so that we can just load in one model, okay? We're going to need to load in multiple models and then move them around. Okay, that's what needs to happen. How are we going to do that? Well, the first thing we need to do, actually, is we need to get TRS, which is transformation rotation scale matrix for each mesh. What is also known as a model matrix. Yeah, I'm not sure. We can check in my old engine what I think it was in GLTF. GLTF node. Was it a GLTF node has a local matrix and a global matrix? And translation, rotation, scale, and that was what it was. I don't think that we have another matrix here. So what I did it was on the, isn't AABB like the fastest thing in the world? I was talking about rendering wireframes for all of the AABBs. If you want to see what I'm talking about, I can turn it on real quick. But we have like many AABBs. Because I was doing draw calls for each one, like this. That's why it's slow. It's just drawing because of that. Maybe some culling? This is just for debug. This is for debug. That's all it is. There's no purpose for it other than figuring out the BVH. If our nodes are good for our BVH, it's not necessary to implement frustum culling for debugs. Anyway, I did it on the level of the GLTF node, because when you implement animations, the nodes have to have their own matrices to move around. Do I want to implement my GLTF parser right now? No, we'll not be doing that. What we should do, though, the way to do it right is you need to have, when you load in a dot object, I feel like sphere versus point. Oh yeah, you're talking about AABs. I thought you were talking about collision in general. Okay, so we want to implement something like this, a structure that when we load in a file, even if it's not a GLTF, it makes a GLTF node, because basically it's just a GLTF without multiple nodes. That's what it is going to be, and it's going to have pretty much exactly this. This is the part of my old engine that I think was actually good, which was like basically when you load in a GLTF or any file, it just makes a GLTF because a GLTF is the most universal thing. It just has all the things. But yeah, the whole system is very complicated, right? So you have skins, you have bones, I have animation channels. And then these are my internal animation structs that once they get loaded in, yeah, it's just a complete fucking mess. We also have GLTF dock, which holds everything inside of it. Yeah, it's a complete fucking mess. And then you have all of the buffers, the buffer view, and the accessor, which is how you read the binary. Right now, what we're gonna do is I'm just going to take this, and this is going to be our model struct. We just aren't going to touch it ever. This model struct never got used. Or maybe it did. But this is the one. This should be the model struct. Number 111, what do you mean? What is that a reference to? Okay, so this... Okay, so we're not going to call it GLTF node. I always really regret... Oh, good luck. Good job. Number one. Yeah, so I always called this GLTF node, and then I regretted it insanely later once I was loading in different file formats, because it's kind of misleading to call it a GLTF node. You also can't call it a node because that doesn't make sense. And you don't want to call it a model because it's often just a node of a model, right? And you could call it a mesh node. Yeah, it could be. Yeah. Yeah, I think mesh node is good actually. Because that's what it basically is. It's just a node that is a mesh. Yeah, let's do it. I always regretted what I called that. Like every time I saw it, I was like, I don't want to have to refactor it because it was like connected to everything, and so I really regretted that. What about the skin? What do you mean? The skin is something different. The skin is this. The skin is the thing that has the joints and the inverse bind matrix to do the animation stuff. So it's a completely separate thing. The skin is also what has the animation. Yeah, but it's not just a mesh. What do you mean? What do you mean? GLTF node makes a lot of sense when it's just a GLTF, but what I'm saying is that but it's not just a mesh. That's why it's a mesh node, right? Because it doubles as a node when you have a full GLTF skin, joints, all of the inverse bind stuff. But also when you load in just a raw .object file with just a bunch of meshes, it also decompiles to a mesh node at the end of the day. This is just the generic. It works for both. It works for both, meshes that are a part of a GLTF model system and meshes that also just exist themselves, right? I need something to bridge the gap between them because you don't just want a bunch of meshes in different places. You need them all kind of contiguous, right? So that's the point here. Okay. I think the mesh UID or the mesh or whatever is the index into the global mesh array. And so I think I'm just going to keep that. I don't know what parent went to, but I think I'm just going to keep this as the mesh struct. And then this will be inside of the actual mesh arrays. And then this is just what's the header that's basically created when a mesh gets created. Or maybe not. Hmm. Hmm. Do I want to just put this all on the thing? There's no point in keeping them separate, no? But I think you might have mesh nodes without meshes due to the whole fucked up GLTF thing. I don't really remember how it works. But I think that's why I had a mesh UID here. Yeah, I think that's what you have to do. Because I think sometimes nodes can refer to the same mesh or something like that. I don't remember, but I think I did that for a reason. I made them separate. Okay. Well, then let's just get ready to get this in. I kind of want to put this in a separate file. The loading stuff in. I don't really want to call it load. Probably gonna call it I don't want to call it parse either. I already have a init. I'm just gonna call it load. I'm sitting here for too long without coding. Init load parse run read. Yeah, I already have. I don't like parse personally because there's just too many things that could be in parse, like the font stuff and just a bunch of JSON stuff. You know, it's like it's just so much. So I'm gonna call it load because that sounds like what it is, I guess. Use load and read. Yeah. I just know that like my the equivalent of load that I had last time, I called it map, was a massive fucking file. Like it was like thousands and thousands of lines. So create, yeah, create is good. Create would be good, yeah. Alright, so I have the load mesh code already in here. We really need to clean it up, but I'm just gonna move it into there because the rest of the stuff inside of here is completely unrelated now. It's other mesh stuff. Like everything that's in here is like set up initial hole points, incremental hole, and GJK, and EPA, right? So it's kind of like collision stuff at the end of the day. And then there was my attempts at mesh decomp. To think that this is only 2,000 lines. My UI library in the old engine was 10,000. That's only 2,000 lines, really? I just want to say what's in this file. So I'm just going to call it incremental whole GJK EPA decomp graveyard. You've been working in collision stuff? What collision stuff have you been working on? Okay. So let's get in the stuff. Well, SDF gen falls under that, right? Yeah. Some of my files, I mean, my old engine had like genuinely, like this file is 10,000 lines. Like just straight up 10,000 lines. Just straight up 10,000. The UI one was the biggest one. Oh, no, the UI one was only 8,000. It felt like the UI one was a lot. Yeah, the map one was 6,000. Yeah, there's just a lot of code in that fucking engine. Like, it was ridiculous. Your UI one is big, it's a few thousand. Yeah, the UI shit is just ridiculous. I honestly don't want to do UI in this, or at least my UI system in this. Like, my old UI system was probably like the most general code that I've ever written, in the way that like you could have a UI element that has like animations that aren't just GPU animations, like CPU based vertex interpolation and shit like this. Basically scripts that run when you click a button, when you unclick a button, like all of that. It was just way too much. I'm not doing that again. I'm not, because it's really not worth it. It's just not. Is that the export to PS1 engine? the exporting to PS1 thing was like the smallest part about it. You know? Like that was just like a thing that I just like did for like a week at add-on. But like that engine like was just like months and months and months of my life, you know. The UI streams were particularly just very painful. Very, very painful. Good times, though. Good times. Trip down memory lane. Yeah, I'm not fucking doing that again. Not fucking doing that again. That engine was such a time sink because I refused to hard code anything. I refused. I said, you know, I'm going to make it so that you can make anything. And you know what? Bad idea. Bad fucking idea. Whoever told me that that was a good idea, screw you. That was a bad idea. You have to make compromises. You can't make a UI system like I made it. You can't. I mean, you can, but that's making a UI system, not a game engine. You know what I mean? Like, I don't know. I'm making a game engine so that I can make something with it at this point. You know what I mean? Like, the other engine was just me making it so that, you know, I could make anything with it. It's like, at some point I just realized, holy shit, that's impossible. You can if that's your entire goal. I mean, you have 400 hours of me streaming on this channel if you want to watch me do that. I have 400 hours before I did other things. It was my entire life, you know? So, I gotta get rid of these warnings. I would love if Clang just shut the fuck up about it, to be honest. These materials... I have to do materials at some point, but we aren't gonna worry about that right now. Because I don't really remember how to do it, to be honest. I don't really remember how to do it, and I'm not doing PBR, so who cares? 90s, yeah, oh yeah, 10,000 hours. Malcolm Gladwell. Yeah, fuck that guy. That guy is such a fucking bozo. Okay. We don't have... I don't know why I don't have index buffers. Like, what the fuck is wrong with me? Like, this is like brain dead easy to do index buffers. I just refuse to do it for whatever reason. So we're just going to do that right now because I completely just forgot to do that. And we're just going to we're just going to do this like this. What's the format again? It is VN. It's the exact same, and VT. So it's the exact same order. Okay. It's gonna have scripts and its own ECS shaders. Yeah, that's pretty much what mine had. Like, it all hooked up to like SSBOs and stuff. It was such a fucking time sink though, like seriously. You're guaranteed to have the points first, right? Okay, let me just put this down here so that I don't forget the order. You're supposed to have the points first. You're always gonna parse in the points first, so I don't have to worry about anything else. I just have to figure out a way to reference it. Current match vertices should just like start at 0. So all I have to do is reference it. We don't have to do any realloc. We just go into point. I need to get... I do need to cast the vec though. Text chords is 3, yeah. I actually don't have that on the point struct though. Yeah, I try to make them reusable as well, but there is a point where it does become detrimental. You know, like what I was doing with the UI stuff was genuinely way too fucking much. Way too fucking much. I don't know. Okay. Point index by... How do I do that again? Hold on. Oh no, they don't go in order. Right. Oh, that's such a pain in the ass. Wait, no. No, but... That is kind of an absolute pain in the ass. Yeah, so we need to actually undo this and just deduplicate normally. I don't know why I thought that I could do that, because I didn't do that before. I can deduplicate after. But yeah, I kind of wanted to do it on the way in if there was a way, but yeah. Alright, this is... I was right, this is a Vec 2. I don't know why I doubted myself. Just exponentially increases the time spent. Sometimes it's good to just mindlessly hack to learn new stuff. Yeah, it was nice to hack, and I did learn a lot from all of it, if I'm being honest, right? Like, I learned like an insane amount of shit about like basically everything in computer programming. But also, like, did that end up helping me get hired? No. So no. What do I... It's UVs. Okay. Yeah, so I can deduplicate after, it's fine. I don't think that they deduplicate inside, but yeah, it is what it is. Okay. So when I load this in, I want to... Okay, so we need to create a new asset. That's going to be my next thing. Very simply, an asset will have... I'm just going to leave it at 128. For now, I think that that's it. I'm going to leave it as ints. We may have a use for a -1 later. Now the question is, do we want to index into mesh nodes and then go down from there, or do we want to go straight into mesh? Like that's the question, because we have this abstraction over it. I don't know. For now, I will go through the mesh node abstraction straight from the asset. We're just going to make an array of meshes here, and then we will go inside the mesh nodes and then go from the mesh node to the mesh. It's a tiny indirection and it'll probably be useful, I guess. I don't like unnecessary, because now we've got asset.meshes.mesh as an index into the globals, so right now it's fine because it's only 3, but if we add like 2 more layers, which we probably will eventually, then you're going to end up with code like I had in the other engine that was just like really, really ridiculous. Okay. So here we go, globals.meshes. Globals is the next thing that we have to look at. Globals is literally just a struct with all of our shit. Right now we just have a vector for the meshes. We want a vector for the mesh nodes, and we want a vector for the assets. And it's that simple, right? So when we... Okay, so first of all, in init, we need to do... Let's see if we do this in main already. We need to like get rid of everything in main, by the way. Do I init anything? I don't. Okay. So that's what we need to do. In init, let's make a new function that's just init globals. Let's leave it with a boolean for now. Okay, so what this is going to do is it will init our vectors for the global struct dot meshes, and we will set it to 0 with a type size of mesh. Okay, now that's dealt with. For now, we'll just return true, and we'll just do that at the top here where we do all of our early returns. So if not init globals, just in case malloc fails or whatever. We'll add on to that later. Okay. Moving on. Okay, so now that we have all of our stuff figured out, we have this vector expand here. I don't know where I init the vector for globals meshes. That's the question that I'm asking. Let's see in here. I do it at the bottom. Okay, so this is good. So now we put this into its own function. Good. Okay. So when we're loading in, we at every new mesh we vector expand globals meshes. We also want to obviously expand the mesh nodes. And so we'll have here a mesh node, current mesh node, we also want to make sure, just in case, that there's a file that's broken. If not current mesh continue. I didn't do that earlier, but that's obviously pretty important so that we aren't just reading in garbage. Obviously pretty important. We're just going to do that all the way down at every switch here. Okay, so we have our current mesh node. Where does that get us? We obviously want to, at the very start, is get an asset equals vector expand globals.assets. Oh, I didn't. By 1. And we want our asset. We want to. I'm just going to go with a raw stir copy here. It's not safe. No, it's not. We want to copy into asset name, asset path, file name. Okay, fine. We will do stern copy. The problem with stir copy is that it often just doesn't. Whatever, it's fine. I think it's 126 or 127. I haven't done this in a while. Oh, I'm being fucking stupid. My bad. I was like, why isn't it working? Is that a joke? Is that a joke? Wait, stern copy is unsafe? Why? Wait. Size in bytes. Like, why? Like, why is that a thing? Does stir copy S add like an escape character at least, or is it just like completely fucking useless? Because I'm using stern copy. I'm not that ill. Like, that's like so dumb. I'm sorry. That's so fucking stupid. I didn't have that problem before, where it gets mad at me for doing that. I'm gonna have it as a vector. Vector mesh indices. Because, or actually, let's just do, but we don't know when we're, yeah, let's just do a vector, because we don't actually know how many we're gonna need at the beginning. Adds an argument for the buffer size to avoid an overflow. I mean, I get that, but like, isn't character count the same? Like, stern copy has a character count. I like, what is the? Maybe I'm too stupid to understand why the byte size is different than the character count. But I mean, maybe I don't know. Whatever. Stern copy also has a stern copy S. That's so dumb. Okay, so when we push a new mesh, we want to push also. We're gonna vector expand. Okay, so now we have indices from the mesh node into here. We also want to do the other way around. So current mesh node. Hold on, this mem sets it to 0. Okay, so let's do that before we start filling it with data. So let's go current mesh. Mesh node equals globals dot mesh nodes dot count -1. Accidentally missing. Oh, in the tree. Okay, so now I've linked everything together, other than the mesh, which will be, this is kind of a mess, like, I'm not gonna lie. Okay, so that's the current mesh node to the mesh. We want the current mesh node parent equals -1, and I'll have the skin equals -1. But I've debugged and went over every part of SCF gen. Oh, you're not? Oh, nice. For the top node? So it's the build or traversal that's the issue. Really? The traversal? I feel like traversal has to be the simplest part, no? Or something, right? I feel like most of my bugs with it have come from like the build rather than the traversal, unless you're doing like really crazy stuff. But I'm thinking like, how do I get the I don't want to stir talk. Let's try it. Let's give it like 420 for the jokes. No, it's actually just a char pointer. I'm doing stir talk. Line? Wait, is this line? And the delimiter will be space. Incompatible integer to pointer. Is it just... Okay, there we go. And now you do this stern copy into the name. This is some really dangerous code. Don't try this at home. Why do you use Malik versus doing arenas? There's no point in doing an arena right now when I'm, it's just such an unnecessary like time sink to set up something for that. Like it's just ridiculous. Like once I get to a point where I can do that, everything is at a point where it's like easily refactorable into that. But like if I have to figure out, like about like memory fragmentation and stuff right now, like it's just so unnecessary. It's really unnecessary to do right now. I'd rather just have stuff that works and vectors that just work, without having to deal with that, when I'm loading in my first model. It's kind of like completely unnecessary to create that abstraction. I'm just gonna do the thing where I'm just gonna put the escape character on it. I think that's safe for you to do. At least that's what I've done in the past, and it seems fine. Okay. Okay, how do I... The question is, how do I test that all of this works? That's the fun part. You don't. Well, I think honestly it'll probably just like seg fault if it doesn't work, so... Why is this not... Why is this not giving me... I have no clue why it's not giving me any problems, but I have to update the make file anyway. Run and see if it crashes? Yeah, that's what I'm gonna do. But the thing is, we don't actually touch any of the shit that we just did. We don't actually touch any of it, so if it doesn't crash, it doesn't really mean anything, you know? It's hitting leaves instead of top or bottom. Oh, I see. But for me, all the data is in the leaves. That's the thing. But maybe for you, it's different. Okay. So how do I test it? Well, what I was going to do was I was going to do the TRSs. Now, do I really remember how to do that? I don't. I really don't. In here, do they have... I don't think that they do. They have S0? Okay, so then what I should do on the mesh node is literally just have it so that we can set... we want to set the rotation scale and translation to normal values, because I don't think that they have it when you load it in from here, or maybe it's just not apparent here and I need to do a different one, but whatever. I forget. I think it's this. I don't really remember. And then scale is 111, right? Well, I did that in a fucked up way. Scale and then translation. Okay. Now, how do I put this into a matrix again? Oh, shit. Compose TRS from vectors. That's the function. That's the fucking function that I'm talking about. That's the fucking function that I'm talking about. Exactly what I wanted to see. We're just gonna slap that in utilities. Can I inline this? Is that... Yeah. I think we're gonna get away with that. I do need all of the other fucking dog shit that's in there, which is... I already have mul m4v4 apparently. I need to find mat for translation. Okay. Yeah, all of this was at the same... All of this is at the same point that all of this is when I was doing the GLTF shit. You can tell because it's cursed. Mat 4 from Quat. What's TRS? Translation, rotation, and scale. You hate to see it. You hate to see it. And now we're just going to do the curse thing, which is just Just inlining all of this, which should be completely legal. Unless you misspell static, then it's not legal. God, it would be so nice, but because of the stupid fucking brackets, I can't do multiple cursor on that. It's just so fucking annoying. Okay, we're almost done. I'm almost done. Okay. Fucking thank God it's over. Okay, so compose TRS from vectors is what we will put in our local. I don't really remember which one it is, but we're just gonna put it in both. Compose TRS from vectors. You are ancient? I'm ancient? What do you mean? Anything tip ring sleeve? I have no clue what that is. I have no clue what that is. So I don't really know the difference between local and global anymore. I mean, I'd have to read the code to remember. But we have it. We fucking have it. And now the best part about this is that we can now pass it as a uniform to our other shit, which is exactly what we want. If I can remember how to pass a mat4, then that would be absolutely lovely. I would be so ecstatic. We have to figure out how to do that though. So that is kind of the problem. Matrix. See, there's a lot here, which is like the problem with me is that I think it's 4FV. I correct me if I'm wrong, but I think it's 4FV. And we're just gonna let it rock with that. And we can take that into here. Uniform in mat for I guess model matrix, is that what the kids on the block call it? And we're just gonna pass that lovely person in. I just called it model. That's what I just called it. Okay, so we have to, let's just get mesh node. It's a vector, so I have to cast it. Cursed. Auxiliary, you got TRS and TRS being that, but with a mic line extra? What are you smoking, bro? What? What are you fucking smoking? Maybe what you said does make sense and I'm stupid. What the fuck is in this, bro? Did I not call this mesh nodes? Like, what? I did call it mesh nodes. Shut up, bro. This is fucking freaking me out. Okay, we're done. We're done. And then we just pass in the local matrix. Okay, we have a second here. So the count is 1. The transpose is 0. I think it's mad because it needs us to cast it to const gl float pointer. Is that it? Yes. Okay, now a few questions here. So let's try when we load it in, since we don't really have a thing to change it during runtime yet. Let's try to move it 100 to in the X direction, just so that it's nice and clear. Okay, it didn't do shit. Oh, it's because I didn't actually multiply it. I'm doing that right? Definitely. Oh my gosh, we've set up the pipeline. Should I make some headway with my engine today, or should I develop my compiler? Well, I mean, my vote goes to engine personally. Okay, we're locked the fuck in. We are locked the fuck in. It's actually crazy that we have the pipeline set up. That's actually nuts. I just want to be funny for a second. Hold on. I need to be funny. We're making a lot of progress. Because the last time I did this in my old engine, it took a hot minute to figure it out. Oh, we passed in the local. We passed into the local. That's the problem. Whoa! What the fuck? Holy shit, it's like Interstellar. Okay, yeah, I forgot about this. You have to... Quat from axis angle. There was a thing. It's like rotate vec2 signed angle. I think it's something to do here, but I need to figure out. I have no clue how to do it. I'm not gonna lie. I'm gonna keep it a buck. It could be fucking anywhere. Like anywhere in this 10,000 lines of code. Fuck. Do I have a rotate in here? Rotate vec2. No. Quat from axis angle. is probably something like that. Holy fucking shit, chill. I don't know what the final angle is. And then this is the thing that you're dotting it with for the axis. I think it's something like that. There we go, there we go. You have to do some quad from axis angle. Yeah. And then if you change the axis, then it just changed which axis it rotates it on. Alright, pretty cool. Pretty cool. Okay, we have a model matrix. Boom. Okay, so what next? What next? The thing, so here's the thing, right? Oh, did you send me something? I'll take a look at it. I think what I want to do is I want to try to now rotate some objects and then try to see if we can run GJK on them and collide with them as we go through them. That's something I want to do. I also want to, okay, so here's something. There's also the thing where now that we have these things, I want to see all of the meshes in the scene. I need to build a BVH over all of them. Of course, there's an immediate problem that comes to mind, which is the fact that we don't have a lot of meshes. We just duplicate the same one. We also could figure out how to do that rather than loading in the same asset multiple times. Instance it. There's a lot. For now, I think when we load in an asset, we should save which file type it is to know when we duplicate it how to duplicate it, because if it's a GLTF we need to duplicate a lot more than just the mesh. You smell me? It's hard to think of next steps for Untitled 3DC project. Yeah, there's a lot of like shit that you gotta implement before you gone. The idea for the project was like a game that like plays itself sort of thing. Yeah. But anyway. You don't want to duplicate the triangles. So that's the thing where my old thing used to be just like massive buffers for different VBOs that then got resized later. So maybe I should make that abstraction. It just kind of seems pretty fucking boring to do that, not gonna lie. Like, that sounds just like a lot of pain for very little reward, if I'm being honest right now. I would rather just load in multiple models as different assets and then let's just figure it out, man. So let's just make a flag here that's just bool is obj. Now this sounds pretty stupid, but it's actually pretty important, I think, to have that. Okay. So we set asset is obj equals true. Equals true. The thing is, when we load something in, we need to figure out if we want to run incremental hole on it or if we don't. So each asset needs to be loaded in with certain flags that say if we want to, if it's going to be a convex hole or what we need to do with it. Because yeah, I don't know what the system I'm going to do for that is, but right now what I'm going to do just to get stuff sorted is I'm just going to load them in separately and then call incremental hole on some and not on others, right? We should also have a couple of booleans inside of here. We can get rid of pause now, by the way. When I have a couple of booleans is bool maybe it just is convex. Hey, what's up? What about a bit flag? I guess. I mean, I don't really know what I'm even doing yet, so that kind of sounds... When we load in a mesh, we need to know for each mesh if we need to run an incremental hole on it and then treat it as a convex hole. Or that it's split up into convex holes. Or we treat it as regular triangles and then build the BVH over the triangles. Let's just call it is convex for now. If hole is valid, this doesn't exist, by the way. It's holes. It's holes. Holes is just an array with 0 if it has one hole or whatever. So it's not. Also, what gets put in holes is the terrain. So that's also a thing. It's just a vector with 0 with one hole, if that's the case. I haven't done mesh decomposition yet to get different holes, so that's that. All right. Let's test this out. Okay, so we load in 2 of the shapes. We just don't draw them. I never made something that actually adds things to the draw buffer, which is pretty admittedly important. I just said that I didn't want to make the abstraction for that, but I feel like we do unfortunately have to do exactly that. The way I think I'm going to do it this time, the way I did it last time was a bit stupid, if I may say so myself. I believe I put it in vertex layout, had a VAO and a VBO. And all of the attributes, all of this shit, very complicated. I think I'm just going to steal the struct. But the render groups are so complicated. It seriously is just insanely fucking complicated. I just realized that now we have the hard part of the engine, which is the rest of the bullshit, you know? It's kind of sucky to have to redo it, kind of. I mean, we're not going to redo the whole thing, but... Okay. So we're not going to worry about the attributes and the render groups for now. These are very complicated ideas. Current offset and current capacity is important, right? Because as we're filling up a GL array buffer or whatever, then we need to figure that out. I don't think that we have index buffers necessarily. We don't have deduplication exactly, so kind of is whatever. I'm not going to worry about that for now. We'll put it inside of load or render. I haven't decided yet. I think I'm just going to put it in render. We already have add mesh to buffer, but it doesn't really seal the deal because it just calls GL buffer data instead of GL buffer sub data. So we need to actually take in, instead of a VBO, we need to take in a vertex layout. We need to take in a vertex layout that has the VBO and VAO on it. So this is going to be the layout VBO, and you can have all of these switches here with GL array buffer, etc. Right now we're just going to have array buffer because I'm kind of getting fucking overwhelmed a bit with it. Just how much shit I have to do. It's GL buffer sub data, not sub buffer data. And we're going to take out the layout offset. Layout current offset. Yeah. Okay, here's what I'm going to do. I'm just going to put inside of here, even though it seems stupid, I'm just going to put meshes. Actually, yeah, let's just make this a vector of meshes that go into this buffer. That sounds really stupid, but it kind of does make sense. And when we add mesh to buffer, then we will just that way we're gonna need to know. The thing is, so when you have buffer data in OpenGL, you need to have a certain thing, and once you exceed that capacity, now you need to reallocate it, right? Just like any sort of thing. So it's important to keep track of which mesh is which, right? So what we want to have for this layout meshes is this isn't going to be a mesh pointer. Let's just have I would love to have the mesh ID. I would absolutely love to have the mesh ID. So I'm going to store it on the mesh struct. Okay, so we got the mesh ID. So now we get our verts go into pause and normal. Let's just make a what the hell? Oh, I didn't. God damn it, my bad. It's gonna be V size. We're gonna malloc V size. And then down here, we're gonna say if layout current offset plus V size is greater than layout current capacity, then we need to resize the buffer, right? Then layout current capacity equals we're just gonna do current capacity times 2 plus layout current offset plus V size, just to be extremely safe. And then we will GL buffer data a blank one to layout current capacity with null, else we will just subdata it naturally. Little bit of an abstraction, so nothing too crazy yet. And then we'll just free verts. Okay, we also here we need to set layout current offset equals 0, and then we will go through all of the meshes inside of meshes, the layout meshes, cast vec layout meshes. It's not actually mesh pointer, this is size T. I less than layout meshes dot count, and for now we're just going to index into globals meshes, and we will add them to the buffer. We're going to make another abstraction here. Fill buffer with mesh try. Oh, this is actually the wrong abstraction too, so we have to figure that out. But this is going to be main vertex. Oh, we're just going to put this in here. We don't actually have tries anymore, so all of these triangles have to be mesh face. So now instead of going into points P into try, all we're going to need to do is get points points, and instead of points P, it's going to be points try indices P. Now do I want to add it all to one thing and then draw it all, or what? Probably want to add it all to one thing. But then I need to know the size of everything. I don't really know the size of everything. I could count, allocate once, and then do it. That would be probably the best way to do it, to be honest. Sorry, I'm just coding away right now. It is kind of hard to do all this abstraction, so I'm having to figure it out. Basically, I just want to make it so that I allocate this v size once instead of allocating a bunch of different buffers and then having to re-upload all of them. And so that's why I have it in 2 different loops here. So that's very simply what I'm doing. Fill buffer with tries though. This I needs to be, we need to have a offset here. And we will do offset plus that. We'll have a size t offset equals 0. Pass in the offset. For here it will always be 0. And now we filled it with that. We're going to free verts. We will upload it to the here using the layout current offset, which will always be 0, using v size, and now our layout current offset will equal v size. Okay, now the only thing in here that's really hard coded is the size of main vertex. The rest is pretty general. So what are we doing? I'm kind of just working on an abstraction for the rendering so that I can, the goal I think for right now is I kind of want to get meshes moving around and see if we can do GJK against those meshes, just like collision resolution against moving objects. So I just thought, oh, that would be cool to do. So that's all I've been working on. Okay, so we do need v size to be out there, actually. We do need v size to be out there. So let's just calculate v size then out here, because it needs to, we need to know what v size is before we go in. But our v size will change here, so that's important because we're redoing everything. Actually, yeah. Interesting. I was also wondering what we're doing in general. So I guess like the idea is like a 3D game engine, like I made one before, but this one I'm kind of making a bit differently. Less general, more like kind of focused. But you know, right now the code that I'm working on exactly here is basically looking at the current rendering draw buffers and then figuring out if we've exceeded the capacity and need to reallocate and stuff like that. So that's like the general idea with the current code right here. I don't think you want to have this. This is going to cause a seg fault for sure. You don't want to do this. You instead want to go through everything and then do this. And then go to v size, because yeah, you want to count everything up and then set it to this. Yeah. Coding your own N64 game. That's sick. That's rad. Yeah, I did some stuff on the PS1. I don't know how similar it is, but that's awesome. I think it got it working, traversing all. Yeah, yeah. What was the thing? What was the problem? So we have add mesh to buffer now, and hopefully we can just you know put this into hopefully we can just put this into main and then just add mesh to these this buffer. Add mesh to buffer. We're going to do MB0, and we need a vertex layout, which will be in our globals. 1 second decrease. Well, I mean, sometimes correctness doesn't mean faster, you know? Sometimes correctness actually means slower. Like in my chess engine, for example. The better I got, the slower I got, you know? That's just how it happens. I'm just going to put it in a function and then forget about it for now. Inside of globals, we are going to need our vertex layouts. Well, no, it's faster. Well, yeah, I know that it's faster, but I mean like, you know, maybe correctness is sometimes sometimes correctness does not mean like an insane improvement, you know? Sometimes it's just important for it to be correct. It has to do when I get into the min distance index. Yeah, stuff like that. Definitely. We're gonna expand by 1. Well, it's good that it works. Yeah. That is pretty solid. Right now we don't care about any of that. All we care about is current capacity equals 0 and current offset equals 0. What else is in here? I know that the meshes. Oh, sorry, I hit the mic. Okay, so we're just gonna put init vertex layouts at the end. It's actually important for it to go at the end because that's after we generate all of our buffers. Okay, so now we should be able to add mesh to buffer with okay. So okay, I'm kind of excited. I'm kind of excited. I'm kind of excited. So we can't just draw this. Now we have to draw each one. from their own offset inside of the buffer. Huh. How did I do this before? Because each draw call needs its own model matrix, right? Even though it's all in the same buffer. Oh, it's still not working. Oh no. It's still not recursing down? What's wrong? Have you tried just like taking min try off and then going by depth instead? I'm just gonna draw meshes. That's what I'm gonna do. Tries are fine, it's the leaves. What do you mean the tries are fine? But that's the leaf cutoff, right? Is min try. That's what I mean. Maybe maybe that's like maybe that's what is causing the issues. The cutoffs for the leaves. Yeah, this is why I put things in render groups, right? Like that was the thing the abstraction that I did in the last engine. Are you still walking wrong? Oh. Yeah, there's probably like some typo or something. Yeah, I mean, for now I could just draw meshes, and on the meshes I could store where they are in the draw buffer. Yeah, let's put it on meshes. Okay, so when we add it to the thing, which is here, when we add it to the thing, we need to change within the meshes. We need to change within the meshes where the offset is. So M, we need to have on here when I draw, is that the correct? I don't think that's the correct thing, right? No, it is. I think. I don't really remember. I don't really remember if it's count or I think it's count and not. I think it's count like that. Okay. So now that we add them all to the buffer, and I want to draw all of the meshes. Fuck you. Okay, let's see how we're gonna segfault here. In main, we have some arrows with the pause, which we shouldn't be doing anything down here. Okay, in init.c we have more stuff with this no member named whole. That is true. That is true. We don't need incremental whole for the player right now. That's next step, but I just deleted the variable, so render.c we have this to comment out. And then we'll revisit that later. Oh my god, there's so much because we deleted that one fucking variable. Fuck you. Okay, we did it. They're both on top of each other, I think. So why isn't the third one? If I just add the third one to the buffer, what's interesting is that it's so far away. Let me test. Let me just not upload the model matrix. Or not use the model matrix, rather. Okay. So we're only getting one. And even when I remove two and only add the last one, we still only get that. Okay. So what am I drawing then? From M offset to M count. What's weird is we don't even add the other one, the one that we're seeing, to the buffer. Or at least we shouldn't be. Okay. So apparently my math is wrong here. Huh. Maybe the offset is not supposed to be in... Maybe the offset is not supposed to be in bytes. I don't really remember. No, it isn't bytes. It isn't bytes. Maybe it is times 3 or times 2 or something. Oh, it is. Oh, okay. Okay, I figured it out. We do need to on mesh load in. Oh, we did have the translate. That's why it was so messed up, because the translation was off. I kind of want to make some of them move. Let's do this. So mb0 dot oh, I have to get the mesh node, right? That's disgusting. Already already hating the fact that I did that, but that's all right. The worst thing is that we actually need to cast this every time we add a new mesh to the buffer, which is like insanely cursed, but whatever. And then MN is the one where we can change the translation. We should really just like create an abstraction that that composes a TRS from from a node. Because that would make things a lot simpler for us. Okay, compose TRS from mesh node now. Now we have that so that so mn local matrix equals compose TRS from mesh node mn. And now we can just do this for each one. I wish that there was like a way to do an abstraction so that we, you know, oh my god, I'm sorry for hitting the mic. And then this one we want to have at -3. And then the final one we want to have a little bit below us, so -2. Okay, let's see if this worked properly. Oh wait, hold on. We're not actually. Oh wait, we are. But we're not in the shader, are we? No, we aren't. All right, let's see. Don't tell me that we're Z down. Maybe I need to cast this like something else. It's not how I render it, right? mn meshes I dot mesh node. Okay. I guess it's going to the wrong one. Okay, so when I load in, do I not? I do expand mesh nodes. I don't know. This is weird. I'm guessing that is all going to the same mesh node. No, it goes to 0, 1, 2. I'm so fucking confused. If they all get a different MN, then why is this a problem? Man, this is so fucking annoying. This is like so fucking stupid. Do you think that I fucked up this? No. No, I don't think I did. I'm in a world of pain right now. I just had an idea. What if it's... Oh, shit. Oh, shit. Okay, so my reallocation thing isn't working for this. Alright, well that sucks. Okay, well at least I know what the problem is now. I still need to figure it out though. In a knit, I did init this vector for it, right? I did. And it is size T. Oh, you know what I didn't do? Before I forget, this isn't the issue, but before I forget, each mesh needs to have its own ID inside of it. Wait, actually, I think this is it. I think that was it. Maybe. Maybe not. We'll try to go back to rendering multiple. Is this supposed to be ×3? I don't think so. Yeah, at that point you're drawing multiple meshes in one. That's the problem. That is the problem. Fuck. Hmm. We just redo it every time. But I think that the redoing is the problem. I think that the redoing is the problem. I could look at how I did this on the other engine. I'm not tripping. This goes into points, right? Current mesh vertices. It casts as a point. I'm gonna get up for a coffee soon. I need to figure this out first, though. I think I'm just gonna print out. There's probably something really stupid that I'm not seeing. Offset 0. We set it to V size at the end. That shouldn't matter though. It sets it to 14,688 at the end. Dude, I'm like losing it right now. I'm gonna just do it manually just because I'm tweaking. Yeah, I think I might just do it manually, just fuck it. Because I like, what the fuck is happening right now? This is target, right? Yeah. I don't think that we're out of space. I think for whatever reason our offset is wrong. Wait, really? Okay, so what dumbass motherfucker is... Oh my god. Why is it when I look this up, it says to give it in bytes, and when it's actually not in bytes? The Google AI overview said, oh, this is in bytes. It's not in fucking bytes. Oh my god, what a waste of fucking time. That pisses me off, man. That just straight up really pisses me off. Jesus. Dude. Like, bro. Like, that's so annoying, by the way. That's so fucking annoying. Whatever. Whatever. I have to go to where we render it and set it to... Okay. Okay, there we go. Oh my gosh, that was such a waste of time. But yeah, our collision probably isn't going to work, huh? Because I translated it down and I haven't done anything different with the collisions. Okay, so after this, the whole point of me doing this is because now I'm gonna do GJK and terrain collisions with the translation matrix. So that was a pain in the ass. Sorry if anybody had to watch that. That fucking pissed me off. I should have... I mean, honestly, though, the fucking printing out didn't help us at all anyway, so I don't feel that bad about it. Obviously, it's not layout current offset. It's... Okay, that's it. Okay. Okay, we got multiple objects drawn and the abstraction for it. When I come back, I'm gonna do GJK. Fix the player hitbox and then the player hole is going to, I want these to like rotate or move back and forth. I'm going to set them up to like linearly interpolate back and forth. And then we'll see if the player can hit them and get moved by them. That's what I'm going to do next. Okay. Alright, my coffee's dripping. Alright, anyway, the abstraction so that we can draw now. So how am I going to make these things move? I'm thinking we just like hard code something for now instead of like creating some crazy abstraction over everything. I think I'm just going to make it so that the first box just goes left and right. Let's make a float t, and it will just move to a certain location and then back from that location. So we'll have a float end equals -3, float start equals 3. Actually, it's starting at -3. Okay, well, if we don't want to make this complicated, let's just go -6 and -3. And how do I make it bounce back and forth? If mn translation dot x is less than or equal to end, then dir equals 1. Else, if mn translation dot x is greater than or equal to start, dir equals -1. And then mn translation dot x is equal 0.02f times dir. And then we have to mn local matrix equals compose TRS from mesh node mn. And there we go. Now we should see the box moving back and forth. Well, it moved to a certain location and then it didn't move anywhere else. So hold on. Am I stupid? Oh, I guess it's... Oh, I guess it's, I guess it gets stuck. Oh wait, I'm so fucking stupid. I'm actually fucking really dumb. Well, that isn't a lot of space to be going back and forth in at all. I thought that would be more. Also, I think that we're doing the wrong one. We should be doing 1. Okay, so we're going back and forth. I want to do 8 and 1. Okay. Okay, my coffee should be dripped by now, so I'm just going to leave this as I go get that. Okay. All right. We have our moving object now. To fix the... Before we can do GJK, obviously, we need to fix the collision holes for players, which I removed just briefly, which is this. The reason why I removed it was because we need to init vector for player dot mesh dot holes, and we're going to initialize it with 1. And then this will become, it's going to be we want to The convex hole will be actually just the cast vec for player dot mesh dot holes. And the rest of this we'll just resolve as hole faces and hole vertices. And that should give us our hole for the player. I want to make sure that that still works because we've done a lot of things after that. And what I will do is I will have the wireframe here, and then we'll just render. When I'm on coffee, I become a good person. I forgot the coffee was still on the screen, so thanks for letting me know. I'm not sure if I become a good person on coffee, not gonna lie. Yeah, this is actually, we need to do something funny here, which is convex hole pointer hole equals cast vec player dot mesh dot holes convex hole, and then just use that. Hole ABB wireframe VBO with an offset of 0. All right, so let's try and render that ABB, and I don't see it anywhere. So that's not good. I still call init player, right? I do. Uh-huh. Do I think that incremental hole is maybe not working, or what could be the problem here? I want to make sure that I'm not rendering it wrong, but I kind of doubt it. Fuck. Why would incremental hole not work? Do I get anything printed out? Let's check that. Let's check out if it gets past setup. That's what I want to know. So we don't have anything going through incremental hole, so that should actually be the only thing that we get printed out. So let me just see. We go through setup. So that means that it goes through here. Let's get rid of clean up hole. Something that I... Okay. Do I have a print AABB? That would be sick. I wish I had that. That would be fucking awesome, man. I probably should have that, huh? But usually I just, you know... Usually I just, show the AABB on the screen by... How did what I did break this? It's two completely different systems. Well, first of all, let's do this. Let's make sure that this is... it should be fine, but... We do init the vectors. That would definitely like give us a seg fault if there was a problem. We do expand faces to 12, which seems wrong. That seems wrong because we don't actually use the faces. But incremental hole doesn't actually use faces anyway. How about this? Let us try and render a known good VBO, a known good AABB, just to prove that the rendering pipeline isn't fucking broken. Does M AABB? Yeah. No, it doesn't show all of them. Oh yeah, those are both of them at origin, right? So we're rendering fine. We're rendering fine. The only way is to do it like this. I'm just gonna do it manually. I'll make this a function later. I'm expecting to see everything at 0. Which fucking sucks because I have no clue. This worked, by the way. This worked earlier. Yeah, all 0. All 0. Let's check it after we do it. Right after we do it, we get 0. Do I ever compute the AABB? Actually? That's gonna be so dumb if I don't do that. That's gonna be like so embarrassing if that's the case. Oh my god, it is the case. I'm so fucking stupid sometimes. Okay, but how is that working before and I didn't even did I take that out of it? The computing of the ABBs or maybe before I was actually rendering out the points or the extents rather than yeah, maybe I was just rendering the points rather than the actual min and max. Oh, well, that was dumb. That was dumb of me. I'm very sorry. Okay. For debug purposes, we have a specific thing inside of render which has this offset. Is this offset? That's a size T offset, not an offset in position, which I want to put in here. You know what we should do right now before I do that? Inside of init.h, we're going to put one externed vec3 cam pause. And this is going to be updated once a frame. I already have it here. I already have this here. Because our camera is a vec4. And getting it to a vec3 is very important so that we don't have to do this shit. Now we're going to take in a vec3 offset. I noticed that most people stream to work on these complex projects, and I want to try it too. Yeah, it's good. It's really good. It's I don't think it makes me necessarily more productive, let's say, but it does make me it gets a bit lonely, you know, when you're working on something in depth for so long and just in silence, you know. So the ability to, you know, to talk to people is quite important, I think, at least for me. It has always been quite helpful because it keeps me from going fucking cuckoo cuckoo, you know. All I'm doing here is I'm making it so that I want to see our AABB as we move around. So I'm just going to add something that I can add an offset. I just fucking banged my eye. Ow. Ow, yeah, fuck. I had some dust in my eye. Okay. I had my dust in my eye, and then I got it, and then I got it too aggressively, and now my eye hurts. Okay. We're putting cam pause in it. Okay, and that's the only place that we have it. So Now when we move, it should move with us, which is what I want. Okay, nice. There we go. Okay, so this is going to be helpful. I want to get rid of this tries 6. Personally, just want to get rid of the tries 6. Oh, that's actually where our collision code. Well, that's where I was headed anyway. What we're going to do now is we will translate all of the collision stuff into the local space of the object. Dustmite and high, yeah. Yeah. Okay. So, depending on if a object is... God, the shit is all over the place in this file. Depending on if a mesh is convex or not, we will treat it differently. Right? For the BVH meshes, we will treat them in the BVH way, right? And the other ones we will just run GJK on instead of doing the triangle tests. So let's deal with that. So the way I had it was M is convex. I don't really know if I should call it that. I think that that's actually a shitty thing. There's two things. It's either a mesh that has convex holes that we need to test GJK on, or it's a mesh like terrain that just has BVH triangles. So yeah. I don't know how to classify which is which and what the name is. All of the names that I can think of are super long. Like, has triangle BVH, or, you know, there's not really a nice way of putting it. I just realized something. You don't put it on the mesh. You put it on the holes themselves. Yeah, because we're iterating through all of the holes anyway. It's just a hole either has a BVH or has a convex hole. Right. BVH prim. If it has, I'm gonna make a thing here. If a hole has BVH over its tries instead of convex hole GJK. Got it. That's what we're gonna call it. We are lagging a bit. The reason why we lag, I think, is actually the Helix autosave thing. I think I just found that out the other day. I was like, oh, well, that makes a lot of sense. Okay, so the holes, we will iterate through the holes now. Do we use J later? We do use J later. We're going to change that because I always use J before K. We of course will have a BVH over this, but I haven't done that yet. Okay, so right now this is all the BVH nodes stuff, but we want to do if. Oh, also let's not forget to change this to K. That could have been a disaster. Okay, if holes j dot BVH prim, then we do all of this. There's a lot of nesting. I can put it in different functions later, but for now we're just going to do this. Else we want to test GJK against it, which was this. And we are using player mesh hole, which obviously won't be player mesh hole. It's going to be the first hole on the player struct. So hole equals cast vec player dot mesh dot holes convex hole, and this will be that hole. And right, so this is the part that's different, because instead of translating by position, we need to translate everything by the mat4. Which is the hard part. What is P, by the way? Collision points. Okay, got it. Yeah, that's hard. I don't know. Let me look this up. Oh, the font, I'm not sure what the font is. I think the font is monospace something. Translate GJK hole into by model matrix. Let's see. Leave the vertices in local space and transform the GJK search directions instead. Instead of moving the entire hole, you keep the vertices in local object space. You transform the direction vector into the hole's local space using the inverse of the model matrix, calculate the support point, and then transform that support point back to world space. Transform the direction vector into local space using the inverse transpose of the 3x3 rotation scale. This is excellently confusing. I wonder if Arya knows how to do this. My GJK works, by the way. It just needs to be... Like, it's very easy for us to just do an offset, right? Like, if I just, like, added all of the, you know, the offset position by a certain amount. But what it doesn't have is the, you know, the rotation. Like, if the object rotates. There is a Kent State University paper. Yeah, this is just what it is. Oh, fuck. I didn't really consider that this would be harder than I thought. If your mono matrix consists only of rotation and translation, then The inverse transpose simplifies to the regular 3x3 rotation matrix of M. Transform. Okay, this is confusing. So, how do I get the 3x3 rotation scale portion of M? Let me see how to do this. This is confusing. Hey, Sophie. You isolate the upper left 3x3 submatrix, compute its inverse, and then transpose the result. Okay. Upper 3x3 of the model matrix. Okay. Let's see if I have this already. It would be with my mat 3 stuff. Mat 3 from mat 4. That sounds exactly like what we want. Mat 3 inverse transpose. So this is exactly what we want. I need to find it though. Okay, so this is exactly what we want. Okay, this is perfect. This is exactly what we want. Just gonna put it in utilities. Okay. We don't even have a mat 3 type. That's how archaic we are. Wait, why don't we have a mat 3 type? Just popping in for a bit. It's been a long day. Well, that's all right. I'm kind of in a good mood because I just got a letter from this job that I walked out on, and they owe me $400, which I'm pretty fucking psyched about. I'm not gonna lie. But where is this type? I mean, that was like, it was like probably over a year ago now. So I mean, it's about time they gave me my money. Does this mean I can buy a new computer? I don't think that $400 in America is gonna get me there. Not gonna lie. Also, I don't know if as soon as I put in my check, if the government is just gonna take it because of my debt, but let's just pretend that we can be happy for a little bit. Let's just be happy for a little bit. Okay. So we do the mat 3 from mat 4, and then we do the mat 3 inverse transpose, and then we put that into GJK. It's RS. Mat 3 from mat 4, and we will give it. Oh wait, this is a const mat 4 pointer. Oh, this is fine. This is fine. This is fine. So this is going to be the mesh dot. Okay, so actually we need to actually get the mesh nodes. And then we get the mesh node pointer mn equals at mn's mesh dot. Wait, why is it mesh dot? Huh? Oh, it's m mesh node, and then from here you just put in mn local matrix like that, and then we have this. So, and then from here we want rs to equal inverse transpose of rs. Okay, so now we give that to GJK. It translates all of the, not the support points, but the direction vectors into that. Yeah, let me go back to this. So we multiply times the direction vector, find the support point, and then transform S local into world space using the full model matrix M. So I don't know how to do that part. Not gonna lie. Let's just take a gander through the math library and see if we have anything. M4 mol. M4 transpose compose 2D transform. Feb4 normalize. I definitely have this. Is it possible that I don't have this? Maybe. Vec3 scale, no. I thought it was mul M4 V4. That might be it. How everyone's doing? It good. I like how the lambda looks like such a clean symbol. That's true. Thanks for stopping by and saying hi. I appreciate that. Mul M4 V4. I think this is it. I can't remember if you're supposed to... I can't remember if you're supposed to... Oh, I already have it. I think if you're doing a point, then you do 0 at the end. I can't remember. I'm not gonna lie. But we're gonna figure it out. We're inlining all of it. I don't give a shit. Cry. Okay, moving on. So now instead of giving it mpos, we'll give it rs and the model matrix. Okay, so instead of B offset, we'll have mat3 IRS. Oh my god, the IRS. Oh no! Sorry. Okay. So when we get a support point, we need to change the dir and before and then after. B offset doesn't matter. In fact, let's just make this 0, 0, 0 and just ignore it right now. Okay, so we need to transform the direction vector by the mat3. Okay. Do I just multiply? I think I just standard matrix vector multiplication. Got it. I definitely have this somewhere. Mat3 mol vec3. That's what we're looking for. Fuck you. Why do you have to make some function static? They're in headers. So I just static inline when it's in a header. Just by default. Okay. IRS with our direction vector. I wonder if we want to make a different dir or if this dir is okay to live on in life. Let's just not worry about it for now. We want to change our support point. So our support dot the A and the B is a bit weird, but let's not worry about it. So the support.p equals vec3 mat4 mol mat3 mol point. Wait, I have this. Model matrix and support.p. Okay, we're in fucking business, bro. We're in fucking business. What is this? EPA. For now, let's just not even worry about EPA. Well, we kind of do, bro. Okay. Let's just not worry about it. Let's literally not worry about it. The normal is the problem. We don't know what the normal of the surface is going to be, but that's all right. I just want to see if we can register some collisions in relatively the right place. We have a bunch of errors because of this bullshit. So these functions and their definitions are all within the header files. Some of them. The math matrix and the math utilities are on the header to be inlined. Camera. Okay, it looks like we're fine. At least so far we're fine. Okay. Okay, here's what I didn't do, is I didn't go through beforehand and mark the meshes differently. Or the holes differently, rather. Hole, what did I call it? BVH prim equals true. Okay. Well, that's immediately not right to me. Oh, it's because I didn't do that. Okay, so that doesn't work, but okay. Whole BVH prim equals true. Other than that, I need to actually translate the point by the... Here I need to translate it as well by the model matrix. Huh. I'm gonna guess that I can move proposed into... I'm gonna guess that I can move proposed into let's see this. Mat for mole point with proposed. Let's see if this works. And let's use the we're gonna put this up here. Okay, that did not seem to work as planned. All right, peace out. 3 like share. Thanks for hanging out. Maybe instead of multiplying proposed, I need to multiply those points. Yeah, maybe that's true. Let's try that before I go and look it up. Because it's probably just going to make me more confused. I was trying to Google that for a second, and then I was like, oh, this is going to be one of these things that's like, nobody's going to know what I'm talking about. Alright, let's see. Maybe I just get it by accident. Oh my gosh, I think I did. No, I didn't. I didn't. If I just do... If I just do this, does this work? Just the translation? Is my understanding of this good enough? No. Oh, wait a second, wait a second, wait a second, wait a second. Oh, it's because we didn't... Oh, it's because... It's because we weren't traversing the tree with the translation in mind. I just had to stare at the screen for long enough and then I got it. Except I didn't get it because this still doesn't fucking work. It's throwing server errors, right? Did your PR from the other day work? What? Oh, whoops. I'm lazy, just do this. They told me to open it in a different branch. That's some bureaucracy right there. I don't think you need a yeah, moving both of them over definitely isn't going to work. I don't understand why this isn't working. I want to try something. Let me see if if this works if I move it back to 0. Yeah, then it works fine. Do we tell them to merge it themselves because it's throwing errors, or just wait it out? I don't know. You might cause some problems if you do that. I would be pretty worried. Actually, hold on a second. I wouldn't poke the bear. Keep throwing a 504 error. Is it GitHub or what? Oh fuck. Oh wait, I didn't. Fucking Christ, man. Why? 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 Why do you not work, man? Oh, it's because I did this. Oh shit. Oh, nah way. Nah way. No way. Holy shit. I did it. I did it. I did it. Okay, I was about to like legitimately like go sicko mode. I was gonna hurt somebody, bro. I'm so glad. You should be so glad that I figured this out, because I would have. You might have been next. That's all I gotta say about it. Okay, so how do I... Okay, so we're using the negative translation. Multiplying a matrix by the mirrors it flips that point. Okay, so what you're telling me, so here's what you're telling me. You're telling me that if I go mat4 model equals mn local matrix, and then I go model equals inverse mat4 inverse, or do I not need the inverse? Do I just like straight up negate the whole thing, bro? Finally, it did it. That's good. At least it got through. Flips that point along that axis. I don't think we're supposed to take the inverse. I think we're literally supposed to multiply it times -1. I don't want to have to write it. What if it doesn't even work? Oh, the things I do. Oh, the things I do for coding. Coding, coding. The things I do. The things I do for coding. Coding, coding, coding. The things I do. What texted or Helix? Helix these nuts. Oh yeah. The things I do for coding, coding.